A little bit about temperature for chemists. Why is it they like to use Kelvin? If that's a measurement that you'll never see on a thermometer, why are scientists so big on it? Let's learn how to interconvert some of the more common methods of measuring temperature: Celsius, Kelvin, and Fahrenheit. This is Screencast 2.4. Well, the SI unit for temperature is Kelvin, but why? It's never negative. That's better for math. So if you double 2 Kelvin, you get 4. What do you get if you double 0 Celsius? Looks like it's still 0, and yet it's 273 Kelvin. You get a lot when you double it. Always use Kelvin when you're doing some math. To go from Kelvin to Celsius, you simply add 273 to that Celsius number, technically 273.15, and you'll get your Kelvin there. For reasons that I think are ridiculous, they're not supposed to say degrees Kelvin, you just say Kelvin. So if we add 273 to that Celsius, we'll get that Kelvin. It's 298. I'm always rounding a little bit, so beware. To go from Fahrenheit to Celsius, here it is for Celsius from Fahrenheit and the reverse. But it might be better if you just write it out, because sometimes people get the order of operations messed up. So here's how you go, how you do it. From Fahrenheit to Celsius, first subtract 32. See how you do that? Then multiply by 5 and divide by 9. In other words, right in order as it looks. Celsius to Fahrenheit, multiply by 9. That's what it looks like. Divide by 5, add 32. So really, if you want to go from one to the other, just follow this in order. Minus 40 degrees Celsius. Let's go to Fahrenheit. So Fahrenheit, we're going to multiply by 9, divide by 5, and add 32. We multiply by 9, we get negative 360. We divide it by 5, we get negative 72. We add 32, and we're at negative 40. Hey, look at that. Negative 40 Celsius equals negative 40 Fahrenheit. That makes sense. Let's see. Negative 40, negative 40. They coincide. And we should get negative 40 Celsius when we do this. Let's go ahead and do this. We'll subtract 32, multiply by 5, and divide by 9. Subtracting 32 gives us a negative 72. Multiplying by 5 gives us a negative 360, and dividing that by 9 gives us the negative 40. That checks. They're the same numbers, and that makes sense. They simply coincide with that particular temperature. This is Screencast 2.4. A little bit about unit prefixes. Those are those words like kilo and milli and micro that you see in front of just about any measurement. Let's learn what they are and what their abbreviations are. This is Screencast 2.3. A billion has 9 zeros. So if you have a billion bytes, that's equal to 1 gigabyte with a capital G. A million, 10 to the 6th, is mega. So a megameter would be a million meters. 1,000, 10 to the 3rd, is a kilo with a little k. Now let's do a few fractions. A hundredth of a meter is a centimeter. 1,000th of a meter is a millimeter. A millionth, do you know this one? Micro. A billionth, nano. And if you want to go one higher and one lower, you could write higher than a billion by 3 orders of magnitude would be a tera. So a terabyte is 10 to the 12th. That's a trillion. And a trillionth, 10 to the minus 12th, is femto. F-E-M-T-O. By the way, notice this weird symbol for micro. It's mu. It's a U with that little line there. Screencast 2.3. Okay, in this lesson we'll learn all about SI units. What is the SI? What are the 7 units that you see here? Including, what are those symbols? What do they stand for? And which of these are actually used? Thinking deeper, can you think of a measurement that's not covered by one of these 7 units of measure, or a combination thereof, for example, mass over volume being density? This is Screencast 2.1. No conversation about data is complete without a discussion of the SI units. The SI stands for Le Système International. It was set up a few decades ago to come up with a common system of units. Think of it as the metric system expanded. Interestingly, about the only country that does not embrace this completely is America, the United States, and to a certain extent England. K stands for Kelvin, which is a measure of temperature. Kelvin is considered the best unit to use for temperature by many since it's accurate when used mathematically, since it cannot go below 0. S is for seconds, a unit of time that's universally used. M is a distance measurement, isn't it, known as the meter. Kg stands for a unit of mass, the kilogram. In this class, G is perfectly acceptable, gram rather than kilogram. I'll bet you haven't heard of the candela, which is used almost not at all to my knowledge for brightness. MOL is used heavily by chemists since it stands for the mole. And it's an amount, a nice amount to use when you have way more than a dozen. It stands for 6 times 10 to the 23, roughly. A is the unit which is known as the ampere, a measurement of electric current, which chemists only rarely use. You can combine these units to come up with all sorts of other different combinations. Speed can be measured in meters per second. Acceleration, meters per second squared. Volume could be length times width times height, so I think you could see how centimeters cubed is a measure of volume. Density, we mentioned earlier, is mass over volume, so we could have grams, the unit of mass, over milliliters, one of the forms of measurement of volume. And the density formula is density equals mass over volume. So if that went away too fast, it's D equals M over V. This is Screencast 2.1.